One of the first things you learn about in correlation is Pearson's R correlation. So imagine you have this data set where you've collected the age and the yearly income of 10 different participants. Here is a graph representing that information. Looking at the graph, looking at the scatter plot, you can see that as age goes up, yearly income also tends to go up. Pearson's R measures the strength of the linear relationship between two variables. Like, for example, these two variables, the relationship seems to be linear. It'd be pretty easy to draw a line through those data points. Now, a few things about Pearson's R. Again, Pearson's R measures the strength of the linear relationship between two variables, and Pearson's R is always between -1 and 1. So for example, your R would be 1 when you have a perfect positive linear relationship. That means as x increases, y increases with it in exactly the same way. You'd have an R of -1 when the opposite is true, when as x increases, y decreases, and the opposite, as when y increases, x decreases. As one thing happens to a variable, the other variable moves perfectly in the opposite direction. That'd be a perfect negative relationship, where R is -1. And an R of 0 is data that has basically no relationship. Just some random points we have here. They don't seem to be related in any way. It'd be very difficult for us to draw a line through that. So let's take our income data, and we're going to try to calculate Pearson's R. Now there are a few different Pearson's R equations you can use. I have this one because, believe it or not, I think it's the easiest one to work with. So the first thing we're going to do is look at this and replace some of the stuff that we already know. We're going to work through this. We know that lowercase n is 10, right? We have 10 subjects. So we're just going to put that in there. Easy. Next, we're going to find the sum of squares for x, basically. We're going to find the sum of all x squared and the sum of all x squared. So for the first part, we square each individual x and then add them together. And for the second part, we add together all the x's and then square them. So we get 15,629 and 136,161. So now we can put those things into the equation. We're working through it. Now we're going to do the same thing for y, where we find the sum of all y squared by squaring each individual y and adding them together. And we get the sum of all y squared by adding together all the y's and then squaring. So we end up with these two gigantic values, which we then put into the equation. So it's looking pretty good. It's still kind of messy, but we filled in a lot of the parts. If we had the top of this fraction, we could solve for r and be done with it. And in order to do that, we're going to need to calculate xy. We're going to multiply every x by every y and create this new column of xy's. So what we need to do is first add together all the x's, add together all the y's, and add together all the xy's, because that's what we need in the top of our equation. So when you add together all the xy's, you see we get a huge number. We get 18,193,000. But these three values can now be put into the equation on the top of the fraction. And now that we have that, we can, with the calculator, solve for r. We slowly simplify that, work our way down, and we find an r of about 0.99. Now what does that mean? It's very close to 1, right? It's almost perfect. X and Y, age and yearly income, have a very strong positive relationship. That is saying that as age increases, yearly income also increases using Pearson's R.